best practices when we're creating a PI classification model. Then we'll talk through performance and tuning of your model, the different ways of deploying your predictive intelligence model, and then we'll wrap it up with additional learning resources. Now, you are welcome to follow along in your instance, and if you want to get a jump start on that, you would go to your instance, open up your instance, go to all predictive intelligence, classification, and solution definition. So that's if you'd like to follow along, or you could just sit back, relax, and watch and kind of think about what we're discussing today. So I built this content to help customers who started using predictive intelligence. And predictive intelligence, if you've gone into it, it's very simple to use. But as you get deeper into it, you're probably starting to stumble along some terms where you're kind of scratching your head going, well, what does this mean? So some of the questions that you might see in our documentation or in the predictive intelligence interface are things such as, artificial intelligence and machine learning, and you'll see those used interchangeably. And so some of the questions I get is artificial intelligence and machine learning the same thing? Or you'll see, supervised and unsupervised machine learning. So what is that and what's the difference? Right away, when you're creating a model, you'll see what is a word corpus. So what is that? As you build out your classification model to predict things such as assignment group or category or priority, you have to select inputs. And so I often get asked, so what inputs should I select? And then when your model is trained, how do you know if it's good enough? And then you'll see these different statistics such as precision and recall, and what are those? And you also see something like a classification threshold. So what does that mean? And then finally, when you get through all that, you have multiple different ways to implement your PI model. And so we're going to cover all these kind of questions and get you comfortable with these basic AI concepts used in predictive intelligence. So let's start with the first question, which is, what is machine learning? And as I mentioned, someone might say AI or machine learning in the same breath. They'll use it interchangeably. But AI is actually this broader domain that encompasses machine learning. And so it encompasses machine learning, encompasses deep learning, and something called natural language processing. And so AI covers things in this broader realm, such as computer vision or voice recognition. So if you're using Alexa or Siri, that would be AI. It also covers things where we give computers the ability to paint art, create music, or write code. Machine learning itself, though, is a subset of artificial intelligence. And this is where we use it to program computers to learn and identify patterns. And this is where predictive intelligence falls in. So predictive intelligence in ServiceNow is actually categorized as machine learning. We also have deep learning in the platform, which is where we use neural nets. And it's called deep learning because there's multiple different processing layers that take an input and then match it and transform it to a specific output. And then we have something called natural language processing, which falls at the intersection of machine learning and deep learning. So if you're using virtual agent, you're using our natural language processing capabilities that you're in that domain. You'll also see in our documentation, supervised, unsupervised. And so classification and regression, which are two of the predictive intelligence algorithms, are considered supervised machine learning algorithms. And all that means is that we teach the model. We train it on historical data with all the past answers. And so data scientists would say data with answers, we call that labeled data. And so, for example, if I go back to predicting the assignment group, we're trying to predict the assignment group. All your incidents or all your cases should have a assignment group already assigned to it. And we're using that to feed into the training data set of the model so that that model knows what the answers are. So when it sees new things come in, it will look back at the historical data, look at the past answers and say, I think it's going to be this. I think the issue when I see, I'm having an issue with Outlook, I think that's a software issue. And that should go to the software assignment group. Unsupervised machine learning is where we find patterns without the answers. So we don't have labeled data in that data set. And so our clustering falls under here. And so we're the unsupervised machine learning models by itself learns and finds patterns and surfaces it back to you. And so we use that unsupervised machine learning, that clustering capability, in some of our solutions, such as automation discovery or clustering, to find automation opportunities. Finally, neural nets. We talked about how it's a deep learning solution that uses both supervised and unsupervised capabilities, and that is also within predictive intelligence. Now, ServiceNow uses AI to improve the experience within the platform, the work experience in the platform. So if I read left to right, these are the 4 core use cases that we focus on. So starting from the left, we use machine learning to discover automation opportunities in your data. So we'll use AI, we'll take a look at your incident data, your case data, your request data, your chat data, and we'll use the AI to find, hey, we found an automation opportunity. We found maybe a lot of hardware issues, and we recommend that you can use this virtual agent topic to troubleshoot hardware issues. Or we'll use the AI to mine your processes. So we can mine your process data to identify bottlenecks when you're moving from different states. So going from open to pending to close to resolve to close, we can mine that and identify bottlenecks and apply all kinds of root cause analysis in your data. The second area that we use AI to improve that experience is we use AI to improve the experience over your incident and case lifecycle. So things like using the AI to route work to the right place and also automate decision logic. So figuring out, like, I'm putting in a change request, and is this change request based on all these different features? Is it a change risk? We also use the AI here to help your agents solve their issues faster. And so I put on the bottom some of the different frameworks that we use to do that, to accomplish that. Classification, similarity, regression are a few. The next one is where we're using AI to predict issues that can cause service outages. And so we try to get ahead of service outages by taking a look at your alert and log data, and then running correlation analysis and pattern analysis to determine if there are certain alerts or logs from, say, your Splunk logs or from ITOM that may attribute to a downtime on a service. Maybe it causes an outage on an Oracle database, causes a server to go down. And so that falls under our predictive AI ops. And then finally, we are able to digitize documents now. So when we combine it with our RPA, our new RPA that came out in March, robotic process automation, with our new document intelligence capabilities, which allows us to read through documents, we can process through stacks of digital documents and pull that information out, automate that processing, and then feed that data into downstream workflows. All right. So I think I mentioned before, AI is an in-platform capability. The AI capabilities are classification, similarity, clustering, regression, and natural language understanding in our search. We use those capabilities into our AI-powered solutions. So you'll see that if you're using Agent Workspace, there's an Agent Assist capability, which allows you to help agents solve problems faster. So that's using those AI capabilities. I talked a little bit about process mining. Well, that's in our process optimization. The virtual agent uses the NLU. So we have a host of AI-powered solutions that use all those AI foundational capabilities. And all of those capabilities can also be embedded into your workflows to make them more intelligent. Okay. And then what's nice is we have the whole infrastructure to take care of all the training and all the prediction for you. All right, so let's talk and get back to classification, which is really the focus of today's conversation and where I want to dive in a little bit deeper. So classification in predictive intelligence is what we call a multi-class classification algorithm. So we look at incidents, for example, and we look at their key features such as short description, location, CI, and we're able to predict an output such as what assignment group would this belong to. So if I feed the algorithm a short description, does it fall in the database? If I look on my right, does it fall into the database category, security or network? Okay. And so we have a number of these models, classification models out of the box, and we use those to predict the assignment group, category, priority, or change risk. So those are some examples. And underneath the covers, predictive intelligence classification is using a default algorithm called logistic regression to sort of make these divides in this visual that I've got on the right here, right? So it's using logistic regression to do that. And then it also has another algorithm called XGBoost, which is an advanced capability and very helpful if you've got skewed data. And I'll get into that, okay? So this is what we're going to talk about. And just to put a picture on how this works in your environment, I'm going to show you an agent workspace, an example. So here in agent workspace, where I can see all of my information as an agent, all of my information around incidents, problems, changes, catalog tasks, I'll go ahead and I'll create a new incident. I've got a mandatory field, so I'll pick a caller, Abraham Lincoln. And so you see, I've got like a blank. I don't have anything in assignment group. I don't have anything in category. I have a default in category. I'm just going to say 11G is out of space. Okay, so I may be a new person right out of college, and I don't know, like, what is 11G is out of space? I have no idea what that is. And so I'm going to use the machine learning, the AI and ServiceNow and predictive intelligence to predict the assignment group, predict the category, but I could have it predict all these different fields. And all these different fields are important because we use these different fields to route this incident to the right place. So if I'm level 1 at a help desk and I can't solve this, I need to figure out who I'm going to send it to, right? And so I am going to trigger this off the save. There's multiple different ways to trigger it. You could trigger it off the tab. You could just have a recommendation pop up. But for simplicity, I'll show you what it looks like when you trigger it off the save. And you can see that I've predicted the database for the assignment group and predicted database for the category. And it's gone ahead and it's changed the default category and it's changed the assignment group to database. And then I could go ahead and save it. It's already saved, so now it can be routed. Now, before I did that, maybe I wanted to tackle this and see if I could solve it. So if I go over to this agent assist, wherever it says similar, these are also machine learning algorithms. So I could say similar resolved incidents. And before I even route this, it'll go out and it will search for similar resolved incidents that look like the problem that I'm trying to solve. And so I see 11G is out of space. And if I scroll down, I can see some other sort of things. And the idea here is I take a look at these incidents and maybe they've got resolution notes that are that I can copy into the actual case incident. So I can go ahead and resolve it quickly. So instead of doing that research, it finds it. So here's a very simple example of using the classification. Now, how did we build that? So if we go into all predictive intelligence, classification, solution definitions is where we define the model. Okay, solutions are the trained models. So I'll click there and then I'm going to do new. And you can follow along if you'd like. But my point here is the actual, and this is, by the way, folks, there's a few other ways to create a classification solution. This is our advanced interface, okay? There's easier ways to do this, but this is our advanced interface. And notice our advanced interface has 4 steps. This is our advanced interface, okay? So I could say predict assignment group, and I'm gonna call it for AI Academy, just so I know that this is different. And then it's going to say step 1, please select a word corpus. Step 2, what are you interested in predicting? What are your input fields? And step 4, add some filter criteria. Okay, so why don't we go ahead and fill this out. And then I'm going to talk about what's behind all of this. Okay, because there might be some terms here like word corpus that you're not familiar with. And what is this doing? Or output field, like what do I need to worry about in picking, what's a good output field? So in classification and regression, we can skip the step 1, word corpus, okay? And because we'll auto-generate the word corpus, and I'll come back to this. In step 2, what are we interested in predicting? So I'm going to go off the incident table. I'm going to select incident, and I want to predict the assignment group because that's what we've been talking about. Step 3, what input data is helpful to predict the output field? So I'm going to click the slush bucket button here. I'm going to grab short description, for example, but you could grab other fields, right? What you don't want to do is like just mass select things without understanding whether or not it's going to help us predict the output field. And that's what we're going to go into. So go ahead and pick short description. And then step 4, if you're following along, pick a filter criteria. I use, for example, created date, created by, and then pick something that will get you to under 50,000 rows. Because if you want to follow along, by the time if you pick under 50,000 rows, like between 30,000 and 50,000, this should train in about 15 to 20 minutes. So go ahead and do a filter criteria here to get you under 50,000 rows and try to get between 30 and 50,000. We've got our processing language, our stop words, and training frequency. And then go ahead and hit submit and train. Now, I'm not going to do it because I've already done mine, but go ahead and hit submit and train on yours, so that by the time we come back to this, it should be trained. Okay, so now that we've got that model set up, we're going to dive into these different steps here. All right, so let me get back here. All right, so let's deep dive into the first step. Okay, so we talked about following along on your instance. Oh, I'll come back to that. All right, so the step 1. So the step 1 we're talking about, it asks, please select a word corpus. Now, I explained that in classification and in regression, we will automatically generate the word corpus based on the input fields that you have selected. Now, what is the word corpus used for? Well, the word corpus allows us to select the vectorization method. All right, what the heck is that? Well, the vectorization method converts all that text, right? You're picking short description or description. It converts all that text into numeric vectors so that it can be used by our AI frameworks, because our AI frameworks, such as classification, regression, clustering, all of them, they don't take text, they take numbers. And so what that does is, and here's an example of vectorization of hello using our paragraph vectorization method, it creates this big numeric vector. And so it's not just converting the hello, it's also when we run vectorization, all these different data points here, these different numbers show the relationship of hello to other words like goodbye, right? Or greeting. And so we do that because now down to this, it's a number, we can plot those words into n-dimensional space, and then we can run linear algebra functions against it. So things like distance. So if I were to vectorize dog and cat, I could run mathematical operations and see that these are very closely related. And so this is where we are using, why we're converting, and why the word corpus, what the word corpus is doing. It's turning all our text into numeric vectors so that we can do this comparison. So we can compare dog and cat, and we know that pizza is far away from dog and cat, so it's not related. Now think about it in terms of, your incidents coming in. I've got an incident that says my email is slow, and then someone says my Outlook email is not working so great. We can convert all those words into these numeric vectors, and we can plot them that they're on an n-dimensional space, and we can see that those two short descriptions are very similar to one another. Okay, and so when you select that word corpus, and again, we just grab the default and we let it do it for us. But when you get into the options, which I'll get to when we're done toward the end, you're going to see 3 different options. You can select paragraph vector. Out in the field, if you Google it, it's actually known as doc2vec, and that's the default. And then there's something called term frequency inverse document frequency. So this is another vectorization technique. And we found this is very helpful if your text has a lot of repetitive data. So think about like machine generated data, like event data, or templated data. You're probably using shortcut templates to auto-populate a short description. So that's very useful for improving the performance of your classification model when you use term frequency, inverse document frequency. And there's something also called GLOVE, or global vector, which is useful for training your models against industry-specific vocabulary. So if you're in a manufacturing or healthcare organization, you may want to try this out. Now, you've got all these options. I always recommend start with the default. Why, you may ask, well, Leonard, why do I even care about all these different options? And I will be going through lots of different options. The reason that you care is when you just use our defaults, it may be good enough, but I've worked with many customers where, they want to improve the model. And sometimes experimenting with these different options, like these different vectorization options or some of the different advanced options, will improve the performance of the model. Okay. So I'm to minimize screen bouncing, I'm going to cover all this stuff and you guys can click and follow along. So wherever I have follow, we're going to come back to this once I get through some of these core slides and we'll see it actually in the product. The step two, what are you interested in predicting? Okay, so what is the output field? In our case, we're trying to predict the assignment group. But it's important before you even go in and build that model. If you want to predict the assignment group, for example, you need to understand and run a report in ServiceNow. You need to understand the shape of the model, of the field that you're trying to predict. So here I've got the assignment group distribution. A normal distribution works best, and you want to avoid what's called a data imbalance, like what we have in this first graph. So imagine these bars is a report where these are all the assignment groups that handle password reset. Now, if you look at this intuitively, the model, if you just feed it a short description as an input, and someone creates a new incident with password reset, where do you think it's going to go? I'm asking that rhetorically. Well, it's going to go to the winner, because if we just use short description, the password's going to fall. It's probably going to, the model's going to look and say, well, my only input is short description, and I'm trying to predict the assignment group. Well, this assignment group handles all the password resets, the majority of them. So I'm going to send it here. Now, and in a lot of, and that's typically not correct, right? Because you may have work in an organization where you have a global service desk and you have like Americas and Asia and Europe, and they all handle password resets. And if you only give it one input, such as short description, it's always going to go to the wrong place. And so we need to understand that shape to say, okay, well, we see that this group, let's say it's Americas, handles most of the password resets. We need to add additional inputs so we know if someone is has a password issue, reset issue from Europe, we want to send it to the Europe assignment group that handles password resets. Another thing is, so we want it to look more like the bottom graph here, where it's a little bit more distributed, evenly distributed. Another thing is the output field that we're trying to predict is we want to make sure that it doesn't have any null fields, doesn't have any different languages in it. You know, if you're predicting for English, it should all be English. If you're predicting for, you know, Dutch, it should all be Dutch. And it shouldn't have any weird abnormal characters, because that'll throw the algorithm off. So that's the first sort of like advice is and recommendation is just visualize your data, visualize the field that you're trying to predict. And then what we're going to do is we're going to take a look at the input data. That's the step 3. So as I showed before, you need to pick some input fields that will help you predict the output fields. And I showed an exaggerated example of where I selected a whole bunch. And that's not good practice. So you want to understand which inputs are highly correlated to the classification output. And you can do this by running a script. And we're going to get to this. I'm going to post this this into the chat so you all can try it. You probably can't run anything right now because your model is probably training, or you can try this against an existing model, but we'll get back to this. But basically what the script is going to do, see here on the right, I'm trying to predict the assignment group. It's going to say these input fields, subcategory, category, et cetera, it's going to give a model improvement number. And that model improvement is the correlation between the input field to the output field. And so the closer it is to 1, the more highly correlated it is to predict the assignment group. So we can kind of sort through some of the input fields and pick the ones that are going to help us predict the assignment group. And if you have any questions, please do put them in the Q&A. My peers on the phone will answer it, and if we have time toward the end, I'll look through the questions that are unanswered and I'll address them. So we'll get into this. You'll have a chance to try this out toward the end. That script also does something where it takes a look at the input fields and it identifies the density. And so when I said, you know, make sure your input fields don't have any nulls, and so run that script to identify that. So the closer to it is to 1 means that it's most likely 100% of the fields are populated, right? And so we can see, you know, short description, these all look good. Anything below that, like alternative contact phone, we may not want to use that because it means 40% of the data is blank, okay? And so I've got some other examples here of, you know, I'm trying to predict in English, but I've got some Chinese characters in there. I might have some special characters in there. So you want to avoid that kind of data. Also, if you are, you want to separate out, if you're running machine learning against event data, machine generated data, you want to separate that out, okay? So you want to have a model that will predict event data and maybe a model that will predict against human generated data, okay? And then the final step, which is what historical data do you want to use? So this is where you are, when I talked about supervised machine learning, you have to teach it, right? And so this is the data that you're going to send to the model to teach it. This is what we call the training set. And so here, you want to make sure that you pick data that you know is relevant, is current, that has all the answers that you want this model to learn from. And so this is what we're actually doing. And so what we do here is that in this final step, right, we went through 4 steps. We're defining what we call a 70 to 30% split. And I have some code. If you had to write out the code, I have an example of what we would do this. This is Python code, one of the popular data science languages. You can see here we're splitting out the test side. So we do this for you. So in ServiceNow, we split this out, but this is what's going on behind the scenes when you define that step 4. You're defining a training set and a test set. And because of that, we know the answers. And you'll see that when we go and look at the model performance. All right. So we just went through some of the things behind the scenes. And now what we're going to do is we can go into our instance and just explore some of this. So here's where we started with predicting the assignment group, right? And you should have hit submit and train. There's that word corpus, and we're going to get into this, but if we leave it blank, we're going to auto-generate it. If I go ahead and just save this, we'll get the related list. Yeah, so you have to have a minimum number of records. I think it's at least 10,000. So let me try saving that again. So I'm going to remove all my training conditions because I don't have a lot of data on this instance. So I've got 50,000. And so when you do that, you'll have the related links show up. Yours should be training, but under advanced solution settings, I can go into new and I can select those different algorithms like XGBoost. Remember, I talked about that earlier, where if your data is skewed, this is a great algorithm to help you run a more effective classification solution. We've got the TF-IDF, we've got some of those other solutions there. So that looks all good. Now, in terms of the word corpus, I talked about this a little bit. And the word corpus, if we go all word corpus and we get into it, you'll see all the default word corpuses. And I'll select one of them, but you can create a new one. And this is where you can select the different vectorization techniques that I talked about. Again, paragraph vectors are default. TF-IDF is great if you are have a lot of repetitive data, or if you have templated data that you're using to fill in the short description. And then pre-trained is what our global vector, or GLOV. That's where you have the industry sort of term. So this is where you would select the different vectorization techniques. All right, I'm going to pause before we jump in and take a look at the questions. Marcel's got that. Hey guys, Marcel, Nabil, are there any questions that we need to answer, or we okay?
Yeah, Leonard, the only question comes from one of our audience members, and the question was, where in the platform do we have deep learning? And, yep. Others feel free to chime in, but, our response is there's areas that kind of span, the space of natural language processing, deep learning, machine learning, et cetera. And in the Q&A, I listed out some of the different areas where you may see some different models, but I want to direct everyone's focus to not getting so much wrapped around the type of model, but how to really engage with the model, how to interpret the model, and then how to understand the model's impact on the end user experience. But I'll open it up to panel members to elaborate.
Yeah, I 100% agree, Marcel. I mean, it's sort of like what we focused on earlier, where we just really want to understand the outcomes that we're trying to achieve with the AI, right? We're trying to improve the work experience. And so we really try not to focus on so much that we're using clustering or process mining. We're really just trying to use it to identify patterns. Now, Yeah, Marcel, you're absolutely right. In natural language processing, we've got deep learning models um, under safe harbor. As we move into Utah, we'll be using those deep learning models, also for classification as well, and as well as in other areas.
Yeah, and Leonard, one comment, and I think this may be worth mentioning, is because we're talking a lot about data and we're talking a lot about input fields and how they're going to be good indicators or predictors of output fields. But do you want to share a little bit what happens if you don't have great data today? Meaning you're pulling data out of a legacy system, or you're new to ServiceNow, or you've changed your processes over the course of the last several years, and maybe your data is in all sorts of different formats. Can you share any best practices on how to get started?
So in terms of, right, you want to pick the data that is going to help the model be the most successful. Now, you can experiment. I think in our documentation, we say a minimum of 30,000 records to get started, but you can bring that down. But often what I recommend is you may need a combination of, the machine learning and maybe the traditional ways of predicting, like the assignment group. So for example, if you only have 10,000 records, but the majority of those can predict these 5 assignment groups very well, but then there's maybe 10 that it can't, we could design the model to predict certain assignment groups and then default back to an assignment rule if the confidence is low. So maybe we know most of our data is we've got 20 assignment groups and we've got 10,000 records, and let's just say only 5 of those we have the majority of the data for. Well, you can design it where you have logic where if the confidence of the model passes like maybe 70%, go ahead and use the prediction. For everything else, go ahead and then use the traditional assignment rules. So there's a multiple ways of tackling it. That one is a common one where we have a hybrid approach where we'll use the machine learning model and we'll test the confidence of it. And if the confidence is high enough, go ahead and use that prediction when we don't have a lot of data. And if it's not confident, then we default back to either the human figures it out, or we have some assignment rule logic that figures out the assignment group. And then over time, hopefully you build enough data where the machine learning can completely take over that analysis or that prediction.
Great point, Leonard. Yeah, so it's important just to get started, even with the records you do have. And what we want to see is incremental improvement. So don't feel like you have to get it perfect the first time out of the gate. Just incremental improvement is the direction we want to see you trending. So no more questions. Leonard, back over to you.
Great. Thanks, Marcel. All right. So you'll get this deck so you can click into it. But let me post this into the chat. Hosted panelists. So everyone. So this is the next step. So all right, cool. All right. So what are we going to do now? So I wanted to get through the slides just to explain some of the concepts. Now we're just going to walk back to our model creation here. So here we had the solution definitions, and we talked about creating that new solution, classification solution to predict the assignment group. We walked through the word corpus. You can see here since I didn't select one, it auto-generated one. And we also quickly went into, and if you blinked, you probably missed it. We went into all word corpus, and I showed you how you can define your own word corpus and select those different vectorization techniques that we talked about. We talked about, taking a look at the output field and seeing, if the output field has any nulls in it, that kind of thing. If it is heavily skewed or imbalanced, and then we talked about that winner take all. Then we talked about the input fields, and instead of just randomly selecting a bunch of input fields, now what we're going to do is we're going to go to this link, and I'm going to show you how to execute some of these scripts that will help you pick the correct input field. So here at the bottom of this article, you'll see, this script, and so you can run this. Now, you have to be an admin on your instance, but you would run this script. You'd copy this, and you would go into background scripts. Okay, leave this page, and you're going to run it. Now, don't don't paste it in yet. Don't run it yet, but I want to walk through this code here. So what this is doing is it's looking at the incident table and it's got an encoded query of short description is not empty. Now, your data, if you're going against your instance, you probably have millions of records. So you're going to want to change this encoded query before you run this. It's got a label, and what this is going to do is it's going to find the eligible input fields for the assignment group, okay? And so I just wanted to show you where you would paste this. You probably don't have time to write the encoded query correctly, and I put a pro tip in here to actually get the encoded query. You're going to find your solution definition where you created, you picked all those different filters, and then you're going to go into the list view and you're just going to copy that query and you're going to post it into that code. Okay, so my recommendation, don't do this right now because you probably want to, write this encoded query correctly so you're not pulling like a million rows. But what we will do is we'll go into this next piece. So after that script is run, we're going to run this piece. And so when you guys run the script, after you fix that encoded query, you're going to go ahead and run this, which allows us to retrieve the results. Okay. And so, let me see here, background script. Guess something, try. Here we go. And so this is what I was showing you in the slide. So here we're predicting, we want to predict the assignment group in our classification solution, and it's going through these input fields and it's picking out the ones that have the highest, that have passed a certain correlation level. And so these might be things that we think about, maybe picking category, right? And it does take some intelligence, right? Because you wouldn't just pick subcategory without category, because you need the subcategory. You need category before you can leverage a subcategory, right, as an input. So we might leverage the category. So it's going through and giving you some ideas of some other input fields that might help you predict the assignment group. And down here is also showing you the potential, like the input fields and their density. Okay. And so it looks like all my input field, all these different input fields are all good because they have quite a bit of data. Okay. All right. So let's kind of get through the performance part, and then we'll sort of wrap up. Okay. So I talked a little bit about this. I gave you some examples, and so this will be here for your reference. The one thing I didn't cover was the confidence threshold. So in PI, when you train the model and you run it, there's a confidence level. That confidence level has to be higher than the threshold in order for PA to actually write the prediction into a designated field. Okay. My whole point with this is I write a lot of our algorithms in Python. This is the beauty of it. You don't have to get a data scientist to use the power of machine learning in the ServiceNow platform. You can just, out of those 4 simple steps, you can go ahead and leverage that machine learning capability. All right, so we went ahead, we trained those models, but we're not done. Okay, so we need to look at whether or not the model is effective. So I'm looking here and I'm seeing that the estimated precision is 76%, the coverage is 77%, and recall is 56%. Is this model good enough to put into production? And the way I always ask customers to look at this is, look at 76%. If we fed the model 100 tickets, it was 100 incidents, it was able to correctly predict 76% of those cases. And then I ask the question, is that better than what you do today? When you're doing assignment group routing, do you route 76% of your incidents correctly? And what percentage gets reassigned? Because if we use 76%, that means 24% gets reassigned. So in order to figure out if 76% is good enough, you need to ask yourself, well, is it better than what we're doing today? And if it's not, then we would spend more time and we would invest the time to find additional inputs, to look for better training data to improve these precision, coverage, and recall capabilities. Now, I'll just use this extreme example where someone may want 100% precision, but there's also this downside because precision will impact recall. And so you may see this, you will see this when you see the stats on the model. So what is recall, right? One concept I want you to understand right away is that precision and recall are inversely related. So if you increase precision, you're going to decrease the recall. And to understand recall, and find that right balance, this is the most technical slide in this presentation, but you need two pieces of information. You need to understand this confusion matrix, where on the diagonal of true positive, true negative, this is what the model is predicting correctly. And the other diagonal, false positive, false negative, this is where the model is predicting incorrectly. And if we look at this model and we say, maybe this model is there to predict cancer. So true positive means the model predicts cancer when the patient has cancer, okay? A false positive model predicts cancer, but the patient doesn't really have cancer. False negative is when the model predicts not cancer, but the real value is cancer. So in a false negative is where I want to draw your attention because of its relationship to recall. You have to ask yourself, when you do these models and you're looking at these statistics with recall, a false negative, a model predicts not cancer, but the patient really has cancer. Is that good? And I ask that rhetorically. Hopefully everyone's saying, no, that's not good. So we want a high recall in those situations where we want to make sure we capture all possible possibilities of cancer. So a higher recall, and so the concept too is these are the formulas, precision and recall. If I look at recall, all it is the number of true positives in the numerator and the denominator plus the false negatives. We can't change the true positives, but we can change this false negative can shift. And so if we just look at this intuitively, and if we want a high recall and we want low, because high recall means false negatives, means that we're reducing false negatives. We want like a higher recall because that means that we have a low false negative count. So we're not going to say someone doesn't have cancer when they really have cancer. And so those are kind of situations where you have to ask yourself, is recall important to you? Okay. And so that's something that you just kind of have to absorb, and you can kind of look back at that and back at the recording, but just think about that cancer example when you're looking at your data. You would relate it maybe to a security breach, right? And predicting security breach. Is it important to capture all potential security breaches? If so, you want a higher recall. Now, here are the different, statistics around the performance of the model. It's really easy when you go in there to go and set the target value. So here, if I increase the precision, it's actually going to go through and decrease the recall. And that's why I wanted to make sure everyone was aware of that recall precision relationship. And here, we can actually go into the trained solution. We can actually go into each of the classes. So here I've got a particular class that I'm predicting, and we can pick the precision and the coverage and the recall that I want. So you can actually go through here and pick that, and we'll take that. We'll look at that really quickly if we have time. But in order to do that, we'll go into all predictive intelligence classification solutions. So let's just do that really quickly. We go into all predictive intelligence and solutions, which are the trained models. Here are those solution statistics. Okay. Here's where we can force the different values. So if I wanted like 100% precision, I could apply that value, but it's going to bring down these other values. And then below here, this is where I can actually drill into some of these predicted classes. These are my assignment groups. And then I can pick the precision, the recall that I want, and then I can apply that to the model. And the model will use what I picked there. Okay. All right. So finally, you've got it all tuned. You've got the model working the way you want, and you're ready to deploy it. So how do you do that? Well, you have three options. You have anywhere you use JavaScript, you can call it the PI model. And the benefit of this is that you've got full control of that model. You can call all kinds of advanced capabilities when you call a PI this way. Customers typically use it, and they call it in a business rule, or they'll call it from a UI action or a macro. But you have full control here, but it requires you to write some JavaScript code and use our ML API. Flow Designer, if you want to integrate this, say like in the beginning, I said, integrate this into your workflow and you don't want to write any code, there is a predictive intelligence spoke that allows you to pick the different models that you've created. And then finally, there's something called PI Workbench, which we didn't get into, but PI Workbench is a guided setup essentially that walks you through a use case where maybe you want to predict the assignment group. And it it goes through all of that in a guided setup, and then it lets you, then you turn it over to allow us to do the integration of the model for you. And so what's beautiful about this is it's really simple to integrate. We handle it all, but you have limited control. Now, I won't get into these because we're almost out of time here, but in the learn more section, these additional classes go through that. So here's an example of a K-21 knowledge class that uses Flow Designer and to implement the solution. Now, if you want to learn more about some of these advanced techniques, you can also go into Now Learning and look at these Predictive Intelligence advanced topics. And some of these other courses, whenever you type in Predictive Intelligence, you'll see a number of them. They also cover some of those different implementation techniques. So with that, I'm going to shut up because I could talk about this for many, many hours. Are there any follow-up final questions we want to ask before we wrap up, Marcel?
Yeah, Leonard, there's one question. So the question is, you mentioned creating separate models in the case of skewed data. Can you give a rule of thumb regarding the number of models we should have in production? For example, a few models is most likely 20 models can make sense. 50 models, you're most likely overdoing it. So any guidance there?
Yeah, right. You don't want, if you're using assignment rules today, you definitely don't want your predictive intelligence models to outnumber your assignment rules, right? So it's some experimentation, but I don't see like that one skewed data balance example I gave with the password reset being handled by multiple global geographies. We were able to condense that down into like 3 models for predicting the assignment group, but we started off with 10. But if you go through and you experiment and you really look at the model, you should be able to bring it down. So you're always wanting to bring the model count down because it makes life easier for you in terms of just maintenance and avoiding that sort of that spaghetti code. But to talk about that, you have a lot of resources, Marcel being one of them, on this phone, where if you reach out to your sales team and you have questions about the proper models, the number of models and things like that, they have access. They can connect you to all the experts at ServiceNow that we're all here to just help you be successful with using predictive intelligence in your environment. So I'll leave. That's how I'd answer that.
Yeah, thanks, Leonard. Yeah, and just keep in mind, simple is better. And Leonard, one thing to point out, I know when you were showing your solution statistics with your precision, your recall, and your coverage numbers, one thing that we've kind of observed is how to take this to the next level. So aside from the model tuning, getting the model performant, oftentimes we see customers struggle with how to communicate what kind of value is the model delivering back to the business. And this is a great area to look at. If you look at your coverage rate, your coverage is really indicating how many of your records are being, essentially solved for with this prediction algorithm. So if you have almost 100% coverage, think about your cost of ticket, your cost of incident, your cost of case, how much of that is being covered by the model, and what's the improvement over the way you were doing it before. So most likely a human intervention way, the cost of that agent's time, or the cost to the service desk. So those are some rough estimates you can begin to apply to communicate to supervisors, business leaders on some of the value that the solution is bringing. So just wanted to point that area out.
Great, Marcel. So we appreciate it. I know we were only supposed to talk for 45 minutes, and we're over by 6. So Marcel, you want to wrap us up if that's cool?
Sure. All right. Well, thanks again, Leonard. This was really, really informative. Again, keep visiting us every other week, every other Wednesday. We will have a variety of topics for you. And again, head out to the AI and Intelligence Community Forum for resources, additional information. We greatly appreciate your attendance and look forward to seeing you next time.
Great. Thanks, everybody.